Yeah, hello Chandar. How are you doing?
I'm fine, sir.
Cool.
So,
Today, huh?
last session I had requested for the question paper format.
Yes. So I had talked to Professor Joshi. So he informed me that there will be 50 questions. That
Okay,
all questions will be MCQ type, like multiple choice
okay,
questions,
good.
and there will be no negative marking. So you will
Okay,
be getting 50 questions MCQ type without any negative marking. So there's a
means,
very pretty simple format for the examination, I
okay,
think.
okay, fine. That's fine. There will be no
Hmm.
descriptive and
Nothing. Nothing.
descriptive and diagrams and numericals.
Huh.
Maybe
No.
maybe few numerical, right?
Maybe like as you are finding in the assignments only the
Okay, okay,
numerical, but you will
okay,
be the answers are there in the form of
okay,
optional choices.
okay, sir. Okay, fine,
Okay.
fine. Thank you,
Yeah.
thank you,
Hmm.
thank you.
So we'll wait for a couple of minutes so that others who are like who may be joining or getting late to join, so they will join, and then we'll start the session because today we have only three three participants, so it's very less number. So if anyone have any query, any question, you can you can discuss it right now. Any kind of issue you are facing while pursuing this course, or any confusion if you have, so we can discuss it. So how are your marks in these assignments? Like if you are submitting your assignment, then till assignment number 6, the marks are announced. How is the performance there? 80. Okay. For others, in all 80. Okay. It's quite consistent in all 80. Sorry. Was I mute something? Okay. Good. So you can expect similar type of questions as in assignment in the final examination. And I hope you all have registered for the examination also, because the last date is something in September only. So if you haven't registered, so can register it as early as possible. Without registering, you will not get any certificate. So the registration is very important for getting a certificate. Hmm. Still no others are joining. So in content of this week, there was no numerical. Uh, Everything was like theoretical things, and mostly from the mechanical background. It was pretty easier week for, I think, this course. Okay, so let's just start. Those who will join late, no issue. We'll see it later. Uh, okay, so hello everyone. I'm Swarit Anand Singh. Those who have joined new or for first time. So for them, I just say that this is a seventh live session which we are conducting uh, for the course of automation in manufacturing, which is offered by NPTEL. And through NPTEL PMRF TA scheme, I got this opportunity to interact with you to take this live session and to resolve your queries and discuss the issues that, if any, if you are facing while pursuing this course. So I hope everyone is enjoying this course and getting some new knowledge from this course, and it must be beneficial for you all. So in this session, again, the format will be same. I will be conducting this session in three parts. So first part, I will be uh, giving you some MCQ type questions so that we can interact and uh, and we can solve those questions. The questions will be mostly related to the course content from week 7 only, and after that I will be taking questions that you have posted or the uh, participants have posted on the question forum, the discussion forum in the course portal. And then in the last session, if you have any query, we can interact directly here only, and you can ask me. So if any confusion or if any issue, if it is there, so you can directly ask to me, and if I will be happy to answer and resolve these queries. So moving forward, we are starting the first session, and the first question is now on your screen. So I request you all to participate in this MCQ type question, answering this question. So the question is, obviously it is a question from the week 7 content. So the question says, in fill in the blanks, which like in which type of automation special purpose equipments are designed and developed, in which the sequence of processing or assembly operation is secured by equipment configuration. So option C, fixed. Okay, two participants have answered. What about rest? C. Okay, any other answer? Question is pretty simple. So Karthik and Vasanta Ram, fixed. Okay, yeah. So answer is fixed. So in fixed type of automation, we used to have a special purpose equipment that are designed for some sequence of processing. So there's a like widely used automation, widely used type of automation in the what you can say industrial Indian industries. Okay, so small scale industries in India mostly use this fixed type of automation. So I think you have good knowledge about programmable type of automation, flexible type of operation automation, and fixed type of automation. So I just wanted you to put the fixed, flexible, and programmable automation in this graph. So this is a plot of production volume. So here on the y-axis we have production volume, and here is a product variety. So I am dividing this graph in 9 blocks. Okay, so like this. So it is a puzzle game kind of. So I'm numbering it 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so now in which quadrant do I place the fixed type of automation? In this graph, where this fixed type of automation is placed. So on the y-axis, you are getting production volume, means in seventh, if you are here in seventh coordinate, the production volume is very low. Here production volume is in middle of something, and here the production volume is high. Similarly, for this product variety also you can check. So in this, here in, like, if you are in seventh column, so the product variety is low. In eighth, product variety increases, and in ninth it is maximum. So accordingly we have to place this. So where we can place the fixed type of automation? So two answers are there. Karthik and T. Sankarlal has said ki fixed automation should be placed here in the place of one, quadrant number one. Now, where will place the programmable type automation? T. Sankarlal saying 5. Okay, so one option is here 5. Karthik is saying 9. Okay. Any other answer? So today we are very less. No, like, if you are knowing the answer, okay, one more answer for here. So you just answer the question, so that the session will be more interactive and it will be more helpful for you also, and it will motivate me to come up with extra energy to conduct this session. Was if it will be like one-sided session, then it will be not like spending 1 hour for this. It will be not much enjoying, right? So it will be good only if you will answer, and will there will be a two-way communication. So still we have 3 answers only. Where we are going to put this programmable type automation? So no answer. Okay. So programmable type of automation, what happens in programmable type automation? So in programmable type of automation, we can produce a variety of products, right? So we can produce large variety of product just by changing the programs. We have to change the program, and then we can get variety of product. But these variety of this production volume is very low. So two things are there: the product variety is very high and production volume is very low. So this quadrant is the suitable quadrant for this programmable type automation, right? And now, like, these two answers are wrong, and the last one is flexible type. So where we will put this flexible type automation? Flexible type automation. Okay, 5. Karthik is saying 5. Any other answer? 5. Okay, 5. Okay. Yeah. So now I think you got the correct understanding that, yeah, flexible is something in between the fixed and programmable. So it can produce good variety, like variety of product, and also in number of volume. So it is more than this programmable kind, but it is less than this fixed one. Okay. So this is how we can plot the production. We can place the type of automation on the production volume versus product variety graph. So here is a graph, the same graph in a more elaborated manner. So in fixed automation, for high volume, it is used for high volume production, as we know, and with a consistent design. So for a single type of design, we used it. So here the positive point of this fixed automation is low unit cost. So the components that are produced having very less unit cost. Okay, and there are lots of, like, mass manufactured products are we can produce uh, products in mass. Okay, but this type of automation is inflexible. So if you want to change the type of product, then you have to change the overall system. So it is inflexible. So this kind of automation is used, like, in a factory where a single type of component, like, suppose if a factory is building some nuts. Okay, so this the quantity of nut we required is in, like, millions of billions of nuts are required. Okay, so this, if a factory is producing a single type of nut, so it can install fixed automation there. But if if they want to change this nut and now they want to produce bolt, so they have to again create another type of automation unit. They cannot produce bolts in the this automation, this fixed type of automation, which is capable of doing nuts, okay, producing nuts. Here in the programmable automation, so programmable automation is for batches with similar design, right? So suppose if you have to machine a, a cylindrical shaft with some specific step diameter, right? So suppose this is of 5 mm and this is of 2 mm diameter, and this kind of structure you have to build, okay, so you have to manufacture. So and then you require this in like thousands of pieces of this, 1,000 piece of this kind of component. So what you will do, you will write a program for this kind of turning operation on an CNC machine, and this kind of component you will just place the workpiece and run that program again and again by for thousands of time, and you will get this kind of component. Now suppose if the design changes and you require this kind of component, right? So again, this is a 2 mm diameter, and then this is the 5 mm diameter. So for this kind of again, it is required in like 500 pieces are required for this kind of this type of workpiece. This type of component is required 500 pieces. So what we'll do, you will again change the program. Okay, you will write another program which will produce this kind of component, right? So this comes under the programmable automation. So programmable automation is, it is used for batch with similar designs. It is reprogrammable, but the reprogramming takes time and resources. Okay, so you are, if you are going to change rewrite the program from here to here, so you have to start from scratch, and it will take considerable amount of time. However, in flexible automation, so in flexible automation, it provides like some ease of uh, uh, some ease of changing the product. Okay, so what you can say, customization. So in the today's world, or in the today's era where we are in, where we are seeing the fourth industrial revolution. So product customization is a in very demand. Like people are demanding customized product. Okay, so everywhere, like you have also seen, like you whenever even uh, in your birthday, you or for any celebration, if you order cake, so you want some customized. You are not going to a bakery and then purchasing the traditional cakes that they have. So you want some customized kind of cake. Okay, so from cake to manufactured component, like if you are going to purchase some vehicle, so you want that your vehicle should be unique. Okay, so what happened, like BMW is manufacturing some series of like series sports series 7. Okay, 7 series vehicle they are making, but you want some customization in that. So if you want to get customized vehicle, now this big companies, big player of like automotive industries, they have provided you this service of customization. Okay, so Royal Enfield and this kind of automotive uh, what you can say manufacturers, they are providing you the customization, a limited customization there. Okay, so if you want a certain type of seat, or if you want a seat for your child, okay, at backside, and then you want some different kind of tail light, or different kind of what you can say sound system. Okay, so they are doing. So this is possible just because of this flexible automation, right? So because of flexible automation, what is there? So there is some fixed what you can say fixed amount of automation, and then some programmable automation, though both are mixed together. Okay, both are augmented together. And if any demand came, like demand changes, so if the component, like they are producing some component type 1, and the another in another time they wanted component type 2, so what we'll do, they have program for this type 1 and also program for type 2. Okay, so they will switch from type 1 to type 2. Okay, set like very quickly. They do not require to write the program like here, and they do not have to change the whole automation like in fixed automation kind of thing. So this is the flexibility. This is known as flexible automation, and there this kind of services or customization is possible. So someone has raised his hand. Let me see. So, anyone want to speak something? And I just didn't remember who has raised the hand. Is there any confusion? Anyone want to discuss anything? Okay, so there's no reply from you guys. Okay, so can somebody give me a good example of flexible automation if you have seen? Anyone in the class? Example of flexible automation. Umbrella. Okay. So how umbrella is a example of flexible automation? Nuts. FMCG. Yeah. TS Roy. What is this? FMCG. So if you have visited like some industries which is having which have employed some robotic arm there, okay. So biscuit and household. I think you guys are getting like not getting my question. So what I am asking, flexible type of automation. Okay, so where you have seen this flexible type of automation? I don't want this product name of product. Just wanted to know where if you have seen any flexible type of automation in any of the industry or any factory, if you have seen, so you can share your experience. Painting. Okay. Okay, so just let me share one. Maybe you can you have seen that. So if you visited some spray painting in automobile, yes. So this automobile, what you can say is automobile production line or assembly line have this flexible automation facility, right? So if it is not there, like earlier they have fixed automation. So you must have seen single type of vehicle, a signal like what you can say earlier stage we have seen maybe the Bajaj scooter. Okay, so all the Bajaj scooter were similar, same color, same everything was same. Okay, then later now you will see lots of options. Okay, so for if there is a if any bike or any car is getting launched in the market, so it comes in different varieties, right? So this all this is possible just because of this flexible automation. So they have flexibility of changing of color, texture, and then flexibility of components also. Okay, according to the price, or we must have heard about like top model, something base model. Okay, so what is their difference? What is the difference there? So in the base model, they have some less number of sensors or components in the vehicle. In the top model, they have extra facilities. Okay, so on the assembly line where this vehicles are getting assembled, so it has flexibility. Okay, right. So in some vehicle they used to place certain kind of like certain kind of sensor. Okay, but in other vehicle they do not put that kind of sensor of motor. Okay, so somewhere you will find power steering, power window, or something like that, but in some other you will not find that. In some vehicle you will find child lock system, but in another you will not find that. Although the build is from like it if Maruti is building some car, okay, so the Maruti car is there, in that only you will find these type of varieties. So all these varieties are just because of this flexible automation. So I was just discussing that in flexible automation you can see in a place where there is robotic arm. Okay, so the robotic arm is employed for pick and place kind of system. So same robotic arm can pick a huge block, okay, and then also a small component. So all this is possible only because of this flexible automation facility, okay. So if it is doing like this, maybe it can also be employed for doing this. We have discussed painting and everything, so it is there. So we have some messages in the chat box. I can read it. Chandakarma is saying ceramic tile manufacturing digital printer. Yes, yes, that is a what you can say, flexible flexible automation kind of thing. Then FMCG sector is a good example. Once, according to requirement, they made chips, and again according need various types of snacks in same production line, simply changing programs. Yes, yes, yeah. So this is a this all is just because of this flexible automation, okay. So this is why that's why we are getting variety of varieties mm, in every sector, you can say, okay. Not only automobile that I have discussed, you can also getting this eatable products, okay, the packet foods. So you are getting varieties of packet foods, varieties of soft drinks, okay. So they are not changing their whole automation system. They are just changing the some program, okay, that is already fixed, that is prefixed, okay, and they are changing it and then getting the variety of product there, right. So I think there are much more discussion we have discussed about this fixed automation, flexible automation, and programmable automation. So now we are moving to the next question. The second question is now on your screen. So the second question is says that which form of the screw thread provide multiple contact point of ball with the screw and nut thread. So answer is Gothic. B, B, B. Okay. Yeah. Yes. So answer is Gothic. So in Gothic form of screw thread, we'll find multiple point of contacts with the ball. Okay. So this is already discussed in the session. You will find the good explanation there only. So for your more visualization, you can just see this. So this is a type of what you can say ball screw system. Okay. So this is a ball screw system. Sorry, so just a minute. I have to represent the screen. Okay. So I hope now the screen is visible. So we have answered this question. Yeah. We are seeing this. So this is the this unit, this black box, and with the this is screw, okay, this one. So this is a ball screw system, okay. So inside it, this kind of the balls are moving, okay, in the groups, and like this screw is rotating, this is rotated by some motor, okay. This is a motor, this may be stepper motor or some servo motor, okay. So this is doing this, and once like this motor is rotating, the shaft is connected with this screw, and because there is a rotation in this screw, the balls are like uh, moving inside it, okay. So there is a groove, there is a passageway provided here inside it, and which is converting this rotation, the rotation of this screw into the translation of this body, okay. So this body is getting translation motion, right. So this is a ball screw system. That is this kind of drive you must have seen in all the automation units from like if you have seen 3D printer or maybe some CNC machines, small scale. So there this kind of system is used. Moving to the third question. So third question is again, it is a very, now I expect a correct answer from you all. So the third question says the component of a part family are to be machined based on their similar manufacturing features. For this purpose, which type of automation would be appropriate? Programmable. Okay, two answers are there. More, one more answers. The component of a part family that are to be machined based on their similar manufacturing features. So for this purpose, which type of automation would be appropriate? Karthik is saying C. Okay. Answer is no, 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 no. So we, in fixed automation, as we discussed, we require, if we require to produce same component, same kind of component over a huge, in a huge volume, then only we go for fixed. Okay. If we want like to produce a component with having similar feature in a batches. Okay. So component of part family. Okay. So there's a like variety of components are there, and like all those components require having some sort of similar features. Okay, so in those kind of for those kind of production unit, we require the programmable type of automation only, right? Not fixed. Fixed will be used where the similar features is required for uh, all the product. Okay, and then there is no variety, there is no change in the variety of the product. Now the fourth question uh, is here. The fourth question says, among which of the following is the example of form closed cam follower system? Form closed cam follower system. Cylindrical cam, B. Okay. Yes, so it's a cylindrical cam. So we'll see, visualize more about this. What is cam and follower system? So you must have studied in the course that what is cam and cam follower system is. So here there's a more visual, for more visualization. I'm showing you this. So this is a cam system. Okay. So this may be attached with some rotating unit, maybe some motor or something like that. Okay, and then this is a follower unit which is what you can say in contact with this cam. Okay, so with the movement of this unit, so this cam will tends to rotate. Okay, and with the rotation, since the outer portion, the outer surface having some different features. So according to this, once it rotates, so according to its feature, the follower here uh, get some motion. So this rotation is converted to some linear motion. Okay, which is having some pattern. So that pattern is defined by this feature. That feature that is on the cam, right? So we'll see a video on that. What are the different kind of follower and cam follower systems are there. Okay, so just like this, there's the rotation here in the cam, and due to that rotation, a pattern you can observe in the follower. Okay, so the cams are classified based on their like different kind of things. So based, first of all, we'll see based on their shape. So based on the shape of the cam. Okay, so they are defined as radial cam, cylindrical cam, wedge cam, conjugate, and all. So this is the radial cam. Okay, so based on the shape of the cam, it is a radial cam. So you'll see that, yeah, this cam is rotating, and then there's a spring here in the follower, and then it is following the pattern. Now in the cylindrical cam, so this cam is of a cylindrical shape, and there is a groove in its body. Okay, so helix kind of a structure is there. So in the groove only the follower is placed, and because of that it is translating, you can say. Now this is a wedge cam. Okay, so this wedge cam, it is moving in what you can say. Uh, it is moving in x in a plane in a x direction. Okay, on x-axis, and then we can say in y-axis this wedge was following it, the follower. This is a globidal cam, you can say. So based on the structure of shape of the cam, we called it globidal, and then based on the structure of this cam, which is in a spherical, so we called it a spherical cam. Okay. So these are the cam and follower system. The according to the need of automation, we utilize it. Now on the basis of type of follower. Previously, we have seen based on the type of cam. Now type of follower. So depending upon the shape of follower, type of follower, we have this kind of cam follower system. So this is the knife edge follower. So if the tip of the follower is very sharp, so will say it is a knife edge follower. Okay. So uh, this kind of innovations have been bought, added to it for more precision, for more precise movement, or for more accurate movement. Now there's a roller follower, so, and then flat face follower. So this face is flat, so we call it flat faced follower. And then a spherical faced follower. So the structure may be in some spherical shape. And now, based on the position of the, there are two types of cam follower in it: inline follower and offline like followers. So these are the various classifications of various type of cam and follower unit that you can see. Okay, so I hope you have got more insights about the cam and follower units. Uh, those who are from mechanical background, they have a detailed course called theory of machine, where they may have studied, or they will study. Those who are in undergraduate first year or second year, or they will study in maybe third year or some later early fourth year. And if you have already studied, so you have already seen about this cam and follower mechanism, and what how these motions are defined, and uh, you must have specified it in more elaborated manner. Now, the fifth question is on your screen. The question says, three-dimensional cam, which is also known as camoid, provides how many degrees of freedom? Sankar says 2. Sanskar Agrawal is saying 3. Okay. So don't confuse with this three-dimensional word. Okay. So it is 3. It doesn't mean that it will give a 3 degrees of freedom. Right. So in earlier, what in the camps that we have seen, cam and follower system that we have seen, like suppose this is the cam, and this was the follower. So what we have seen. So on the rotation of this cam, this follower is just going up and down, right? This follower was going up and down. Okay. So this kind of system, how many degrees of freedom it have? How many degrees of freedom does it have? Anyone? Leave this question now. For this question, I'm asking. Yes, Sanskar. So it has only 1 degree of freedom, right? Because it is following the one, it is doing the motion in one direction only. Yes, it is one. For camoid, this kind of camoid, how many degrees of freedom will be there? So what is camoid kind of cam? Which can provide us not only this transverse motion, but also the rotation. Okay. So if both motions are there, the two types of motions are there, then how many degrees of freedom will be there? 2. Okay. So the correct answer for this question is 2. Now the sixth question is on your screen. Question is, to provide the best performance, it is essential that ball screws should have what kind of property? So it has hard surface and soft core, or hard surface, hard core, or vice versa, or these are the combinations. So what are the answers? Okay, so all the answers are A. Hmm. Right. Answer is also correct. So can somebody tell me why we required hard surface like this? These are the screw balls, right? This. Oh, sorry. I have to draw a spherical ball. Sorry for my poor drawing, but yeah. So the surface, we want this surface to be hard, and inside it we want soft. And this ball is we are using for ball screw system or maybe bearings also. Same ball is used in bearing. So why we want this? So Sanskar is saying hard surface to avoid wear and soft core for good strength. Okay. Any other observation? Anyone else want to say something? Any comment on this? Easy to remove soft core? Hmm, no. So this is a ball. Okay, these are a specific a ball made up of specific materials. Okay. Initially, what happened? This kind of balls are manufactured. Okay, and then these balls are then case hardened. Okay, so like heat treatment operation is performed. Heat treatment has been done to make this surface, the surface more harder. So that operation may be termed as hardening operation, hardening heat treatment. Okay, so for hardening is done so that any scratches or wear should be avoided at the outer surface. Okay, because these balls are always in the contact with the what you can say, this is screw, the passage in the screw. Okay, so these are always in contact with that, and then always in some rotation and uh, movement are there. Okay, so if some wear or tear occur at the surface, so that will be very that will be reduced, that reduce the efficiency of this ball. Okay, and the overall system also. So we require some the ball, the surface of ball to be hard for good strength and wear resistance. Okay, and the core of this is required to be soft. So when we do hardening operation, so the surface become hard, but the inner surface remains soft. Okay, remains like in comparison to this, it remains soft. So this softness will provide us, like suppose they are in the continuous stress. Okay, so they have thermal stresses, they are induced in the other tensile strength and all. Okay, compressive stresses are applied over them. So okay, so if they overall material of like are is hard, so what happened? So the all the stresses that are applied here, it will what you can say, transfer to the inner core, and then from to whole of the this ball. And eventually what will happen? So due to increasing stress, they will broke. Okay, so in a simpler way, you can say, so if it become, if whole body of, or whole like material of this ball is harder, so it can be considered, it can be simplified as a brittle object. Okay, so it will become brittle. Okay, but if it become brittle, so any kind of extra force can break it easily. But we want that but if we want that this ball should be in continuously under loading conditions and different stresses. Okay, so the inner soft core, that is soft, so it will provide some ductility kind of thing. Okay, so what will happen? So it will absorb the stresses that is applied on the hard surface of this ball. It will be absorbed and then damped inside it. Okay, so that it cannot uh, transfer further in the body, and then this will be able to wear like uh, loads and other stresses. Okay, so for this, it is required like a surface is hard and the inner body or the core is soft. Now, moving to the next question, question number 7. Again, it is for the balls only. It is saying in general, the ball is made up of which material, which is used for precision ball screw system. So two answers are there: steel, steel. Any other answer? Copper, aluminum, brass, or steel? Oh, Nagpal is saying aluminum. C, brass. Hmm. Okay, so let's discard the options first. Why not aluminum? Aluminum and copper. Why not aluminum and copper? They are soft material having weak strength, or okay, so these two are not be considered. Brass. Why we not consider brass? Yes, ductile also. Brass, no rusting. Costly. Yes, brass is very costly, and it is not easily machined. Okay, machining is also a difficult task for this. Okay, so that's why this brass is not used, and because these balls are very small, but we required in huge amount. Okay, in a bearing, if you'll see, we required around 20 to 50 small balls. Okay, the small balls are required. So these are very if these are made up of brass, that they will be very costly. Okay, so all the balls all in the bearings or the ball screw system that you see, they all are mostly made up of steel or its alloys. Okay, so with the steel, they have some specific alloys. So different kind of balls are made up of. Uh, Different kind of balls are made with this. Moving to the next question. So the question is again for this screwball system, the shrimp plate based on preloading arrangement generate which type of loading in the nuts and balls? So okay, D answers tensile. Yeah. So answer is D only. So what is shrimp plate? Okay. So you have seen this diagram in the lecture note only. So this is a shrimp plate which is placed in between the two nuts. Okay, to provide the tensile loading on these balls. Okay, so they are providing extra tensile loading in this balls. Okay, so in practically, if you see a real system or real screw ball system, so this is the shrimp plate. Okay, this black is the shrimp plate, or you can say it is a spacer. It is also known as a spacer. So this shrimp plate or a spacer is used for providing or generating the uh, tensile loading, preloading. You can say the tensile preloading in the balls. Moving to the ninth question. Again, it is a question on the type of automation. It says like use of CNC machine tools and industrial robots are the example of which kind of automation? Yes. Everyone answered A. Yes, it is a programmable type of automation. So any CNC machine, if you have, so you have to write a program for a single kind of a kind of component that you have to manufacture, and then once you change the feature of the component, then again you have to change the program. So that is a programmable type of automation. The last question is uh, an assembly of rigid bodies which are connected by joints and that transmits forces, motion and energy is in predetermined manner is called assembly of rigid bodies which are connected by joints and transmit forces, motion and energy is in a predetermined manner is called. Two answers are there. This is called a machine. Yes, this is called a machine. So this rigid body is considered as what? Mechanism, machine, structure, or linkage? Rigid body is. Now I'm asking, what is rigid body? Is it mechanism, machine, structure, or linkage? Frame. Options are four only. I'm giving only four options. Options. Option A, B, C, and D. So what is in which category you will keep these rigid bodies? Mechanism, structure, structure, mechanism. Okay, structure. Okay, so we are getting mixed answer again. So let me explain this thing. So rigid body is the structure. Okay, so suppose sorry, let me make a good drawing for you. I will try my best. Okay, so suppose this is a this is a what you can say, cylinder piston mechanism. Okay, so what happened? So due to the motion of this this piston moves up and down in this cylinder. Okay, so this rigid body, what are the rigid body in this? This is a rigid body. This is a rigid body. Like this is a connector and this is a uh, piston. So these are the rigid body here. Okay, so the rigid body are the structure only. So this rigid body comes in this structure part. Okay, then connected by joints. What are the joints? Joints comes in the linkage part. Okay, so these joints come in the linkage part. So where are the joint? So this is a joint. Okay, so this is a linkage which is linking the connecting rod to the piston. Okay, and then if we consider it, what is like it is transmitting force and motion and energy. Okay, so the phenomena by through which the this transmission is occurring, so it is, sorry, there's a B. So yeah, so the by the phenomena by which this transmission of force and motion and energy is occurring, so we termed it as a mechanism. Okay, and then the overall system, okay, this overall assembly, it is termed as a machine, right? I hope it is clear now. Any confusion in that? Okay, so this is all the 10 MCQs that I have for today's session. Now, next, moving to the question that is posted on the portal. So this week only one question was there, and two questions are there. One was not relevant to this. They have some issue with what you can say, some course content or something like that. So only one question related to the concepts. So the question says, what is the function of brushes and a split ring commutator? Any answer for this question? In DC motors, what is the function of brushes and a split ring commutator? So last week we have discussed this in very elaborated manner. Is there any answer for this? No answer. I'm audible to you all or not? Okay, Karthik is saying to change direction of current. Okay, and what for what these brushes are required? Frictionless current, yes, yes. So this brushes it conduct currents between stationary wires and the moving part, most commonly in the rotating shaft, and the split rings. helps to reverse the direction of the current in the circuit. Okay, so we have seen this video last year in the last session, but again I am playing this video for further more visualization over it. Okay, so these are the brushes, and this is a split ring. Okay, so these brushes are what you can say, in contact with this split ring commutator. So this is completing the circuit, transmitting the current from this part to this part, as you can see in the video, the how this current is reversing and how this current is transmitting from here to here. Okay, so that's all. Like only one question is there. So that's all for this two sections. Now we are open to discuss if you have any problem, if you have any query. So those who have joined late, for your information, if you have not registered for the examination, so please I request you to kindly register for the examination, because the last date is it is going to registration is going to close very soon. So you have to pay the fee and you have to attend the examination so that you can get the certificate for this course. In this course, in the examination, there will be 50 MCQ type questions. Okay, multiple choice questions will be there, and then there will be no negative marking. So last date. Okay, so let me see what is the last date. I received the message also. So you maybe you have seen. um, NPTEL 16, I think. Okay. Yeah, so it is very near. Okay, so I've also received message. I'm not getting. Mm, so you must have got reminder also. Okay, so it is very near. So how CD I get whole lecture recording? CD I get whole lecture recording. So lecture recordings are there on the portal itself, Tias. So what you can do is you have to download every lecture from there. Okay, so they are downloadable. Okay, so it is on the like uh, you can download, or it is on YouTube. Actually, it is hosted on YouTube, so you can watch it also. Okay, time for 50 MCQs. Hmm. So it's a standard time, I think. So it is of like 1.5 hour paper or something like that. So this pattern is very what I was discussing. So the pattern is very lenient. Okay. So if you're getting 50 MCQs and then there is no negative marking, so you cannot any link for payment for. So TS, you can visit this NPTEL course portal. Okay, I will show you. Okay. So just let me finish this discussion. So this 50 MCQ and no negative marking is a most lenient type of examination that you will face. Okay, so this examination will be in offline mode, I think. So or so those who haven't registered for this examination, you can go and register and give the examination. Okay, if you have any query, you can visit my website and contact me if you have any query regarding this course and all. Okay, so this QR will take you to my website or my web page. Okay, so Tias was saying, Karthik is saying, is it offline or online? So it will be decided later, Karthik. Okay. So based on, I think, availability or maybe something like that, most probably they are planning for offline. But if something will not happen, or some arrangement will not happen, so it will be in online mode. Okay. So let me see. I'm now presenting that how to where we can get the where we'll get the NPTEL payment thing. Okay, so so if anyone else any have any query, so just please feel free to ask. In meantime, I'm just searching that. Okay, exam center. Yeah, so all will be. So first of all, TS Roy asked for the payment link only. So this there is a register for certification examination. Okay, so this is a link. So once you log into this portal, Swayam portal, so you will get this. Okay, exam dashboard, and then here you have to fill the form. Okay, so before you start, please go to the timeline and guidelines, final course list, and everything. So just read it, and you will get like, so they are asking for select cities. So after selecting city, you will uh, get to know how to this where will be your center, and this will be offline or online mode examination. So you have to go to the examination center, I think. Okay, and then once you fill this form, you will get the link for payment also. Okay, so you have to upload all these documents and right. So from here you can get all the things about what is required, what is not. Okay, so that's all for today's session. Uh, Thank you very much for attending this session. I hope you have enjoyed it, and see you in next session next Saturday at same time. Till then, happy learning.